All right. My name is Nathan McDonald with the Kudzu Forum, and we're here interviewing our fire starters for the SNS Fire 2014, our 12th year. So congratulations, Vern, for Kymeta.
Thank you very much.
Excited to learn more about what you guys are up to and talk about what's in store for the week ahead here. So if you could, just take a moment, take us back to where all this got started and kind of give us a front row seat to what you guys have developed and where you guys are at today, if you could.
It'd be my pleasure. Well, it's an honor to have been selected as a fire starter this year, and I've never had the privilege of attending a fire starter conference before, but I've been watching from afar for many years and have always admired Mark's work, and it's just a real privilege to be here and start to get acquainted with the team and network with the other selectees. So far, our first few hours here have been just a delight, and we look forward to having a wonderful week.
Terrific.
Kymeta is an unusual company in many ways. It's a company that is marked by extraordinary sponsorship. We are a spin-off from Nathan Myhrvold's Intellectual Ventures, and as you may know, Bill Gates is one of the principal investors in Intellectual Ventures, and also became our anchor investor when the company was spun off. We're also backed by Lux Capital of New York and Liberty Global, as well as Osage Venture Partners and the Kresge Foundation, who came in our last round as co-investment rights with Intellectual Ventures. The company is pioneering the field of metamaterial-based satellite antennas. This is a field of application that comes out of a very large umbrella set of intellectual property that IV acquired over the past decade. And a big part of that intellectual property was created at Duke University. Okay. And our founder and CTO, Dr. Nathan Kuntz, was the lead investigator working with Dr. David Smith in his labs at Duke. As you may know, the field of metamaterials started probably 12, 15 years ago when we were all going to be looking to have optical computers, and we were looking to have optical switches drive our networks in ways that electronically switched networks simply couldn't keep up with. And a lot of money poured into the research, and it had to do with manipulating light in ways that just didn't happen in nature, making it make a U-turn, bending it in ways that sort of broke the laws of physics, if you will, or at least tortured them significantly. And probably the most famous one of those experiments was the invisibility cloak, made extremely famous by Harry Potter, but the real one was built by Dr. Smith and our Dr. Kuntz at Duke, and it was a lab experiment, and I think Nathan has let us know that it was about 40% efficient and very narrow frequency success. So beyond that, it's not likely to be hiding tanks anywhere soon, but as Nathan finished his postdoc, he was looking to try and divine for himself, I guess, what his career path would be, and in talking to his advisor, he suggested, why doesn't he go out to Intellectual Ventures, where Dr. Myhrvold had been acquiring metamaterial patents from all the major research institutes around the world. And Nathan did that, and as he started to look at ways to commercialize some of these unique properties, he had the breakthrough thought of, would the physics and the toolkits that had been developed for the optical domain still function as you came down in frequency into the lower frequency in the electromagnetic spectrum into the RF domain? And to our great blessing, they did. So he in a very focused way, started to apply those techniques to the field of antennas. And millimetric microwave antennas up in the satellite range, the KU band, KA band, became obvious first targets for us. And if Nathan was here, and unfortunately he won't be here until about 8 o'clock tonight, but he'll be giving the speech tomorrow. He has a phrase that he uses to sort of set the stage for us, which is, why do we have geosynchronous satellites? And these are the satellites in 24-hour orbits that don't move relative to the ground. And the answer is because we have stupid antennas. And those large parabolic dish antennas that have evolved to kind of be the backbone of satellite communications are about to be disrupted by a total new generation of flat or conformal, for that matter, antennas that are using our metamaterial technologies to be software-defined, electronically steerable beamforming antennas. So what used to be fixed can now be mobile, opening up a tremendous utility value for low Earth orbiting satellites and the new generation of high throughput satellites. We can start to create enormous new opportunities for the satellite industry that's been lagging, I think, significantly behind the cellular industry and the other terrestrial forms of wireless for the last 15 or 25 years as cellular sort of took off.
Yeah.
Satellites kind of meandered along as a very reliable sort of communications pathway of last resort, largely because they didn't have this technology to leverage the types and kinds of services that we're now enabling.
So is this ultimately a bandwidth solution for the kind of last mile, neighborhood by neighborhood, getting a connection to higher speed data at the? What's really the consumer impact of this technology? Is it going to be? It truly is up at that level.
Yes, it will. It's truly broadband anywhere. It's to be able to provide access via satellite technologies, whether GEO, MEO, or LEO satellites, opening up all types and kinds of new services. The beauty of our technology is the way we manufacture these antennas is able to leverage existing mature consumer electronic manufacturing techniques.
Okay.
So we are benefiting from the computer display industry, which is one of the really breakthrough opportunities we're pursuing at present, is using thin film transistor technology to build our apertures, which means we can enjoy the same kind of volume efficiencies that we see from television sets and computer screens.
So while it costs a lot of money to put satellites up in orbit to produce the consumer receiver or transmitter at the terrestrial level, it's not going to be cost prohibitive to be able to distribute that technology out.
Well, it's not only the inverse of what historically has been the challenge of a relatively expensive ground segment, but even more importantly, nothing is more efficient than satellites for one-to-many distribution of digital information.
Yeah.
The internet today is still a unicast architecture. Every session for every over-the-top download is one consumer terminal talking to a port somewhere in a server farm, probably located next to a hydroelectric power plant. So millions and millions of us are taking down millions and millions of largely the same content in unicast sessions. It's incredibly inefficient. Until today, there really has not been a broadcast extension to the internet. We believe we can start to open up those markets and those new architectures to really bring the internet itself to a whole new generation of efficiency.
And so you've got a tremendous amount of IP and talent, plenty of capital. Where are you guys at in the development cycle with this in terms of getting the technology incorporated into devices and get satellites launched?
So we've crossed that threshold from the research time, which we sort of put a bow on last December 10th, when we did our first actual transmit and receive demonstration from a live satellite. That was a big milestone for us. That marked the switch into the era of product development for us. And since then, we've been actively working both to improve the technology in terms of its functionality, moving into some new architecture designs that we'll not be sharing today, but over the next year you'll be able to see them as they come forward, that improve the performance of our antennas tremendously. I think we're on schedule for our first product launch at the end of Q1 2015. We will come into the marketplace with some fixed and portable solutions, largely aimed at the higher end of the market for large bandwidth applications for first responders, electronic news gathering solutions, and field service engineering organizations. And then rapidly over the coming 18 to 36 months, we'll move into the connected aircraft, the connected maritime applications, sort of the high-end, low-volume, high-value end of the mobile communications applications. And then the big switch for us, and we've been working very diligently with the major automotive manufacturers on their very long lead times, So you'll start to see us emerge with the connected car solutions in 2016, late 2016, early 2017 for aftermarket solutions, and we look to be OEM by 2018.
Wow, tremendous aggressive growth path that you guys have in front of you, but certainly has the capability there to make it very worthwhile and really change the way that people interact with their all different types of appliances and transmit that much more data, that much more efficiently.
I think we've never found an application whenever we can bring more broadband and more bandwidth to consumers and commercial applications. More has never been enough.
It's hard to imagine a better way of doing it than what you guys have come up with here in terms of even that much better. I mean, it's pretty well going to fully, inform everything that's out there that could possibly transmit.
No, indeed. Well, the technologies too. I think it's important probably for something like FiRe to share with the audience that not only, our field of endeavor at present is satellite communications. The core technologies that have been created and are being exploited now, Intellectual Venture has done another spin-off for imaging. Okay. They're looking at some radar applications, and I think the fields of medical and some of the intelligence services are finding other applications that have been problems needing to be solved for a long time, but the ability to have electronic beamforming scannable antennas was the holdup. And just a tremendous amount of applications are starting to proliferate out of that broader field of metamaterials.
So we're here at the Future in Review conference. We're just getting started. Obviously tremendous technology that people will enjoy learning about and seeing where the world's going. But any particular message or thing that you guys are hoping to receive out of the week here with us, both the audience as well as the folks joining us online?
Well, I think clearly the types of audiences that Mark assembles at the FiRe conferences are extraordinary. Yeah. I think the networking opportunities for us just this afternoon and talking to a few of the folks in the waiting room here, we've already made a few sparks. So I think we look forward to seeing how we can maybe create a little bit bigger blaze from your guys hosting us today.
Excellent. Well, congratulations. We look forward to many partnerships to come here, and enjoy the week ahead. And we'll look forward to getting the message out to the audience here this week.
Thank you all. Appreciate your time.